What's going on, everybody? Got another video here for you. This is Applied Calculus Integration by Parts. I do have another lecture video. It's Calculus Integration by Parts. The examples in that video are a little different than this one. So let's go ahead and get started. All right, so integration by parts. If we have the integral of u dv, then that's equal to u times v minus the integral v du. All right, so I think you'll see this a little better once we start working the examples. But basically what we've got to do is we've got to choose something to equal u and something to equal dv. And here's some guidelines for choosing u and dv. It says u is normally chosen such that du dx is of a simpler form than u. So in other words, we're going to let u equal something, and then we're going to take the derivative of that, and we want that derivative to be in a simpler form. And dv is normally chosen such that when we integrate dv, we can easily do it. Okay? I mean, it's usually going to be one of those basic formulas for integrals. All right, so let's go ahead and get started. So let's look at this one. So we want to integrate x sine x. So when we integrate this, what are we going to let u equal? What are we going to let dv equal? Well, if I let u equal sine x, what's the derivative of sine? It's cosine. Is that simpler? Not really. So let's try letting u equal x and dv equal sine x dx. And so now we get du is equal to 1 dx, derivative of x is 1. And then v, well, what's the antiderivative of sine? Well, that's negative cosine. All right. And so what does this up here say? U times dv is equal to u times v minus the integral v du. So u times v, all right, so that's going to equal the integral. That's going to equal negative x cosine x, see, u times v minus du times v. So dx times negative cosine x. Now the negative cosine, that's going to make this a positive in front, and then it's going to be cosine x dx. And so now we can integrate this easily. So that's negative x cosine x. And what's the antiderivative of cosine? Well, that's sine. And then of course, do not forget to put your plus c. All right, so that's basically all it is. Probably the most difficult part, and it's really not that difficult, is choosing u and dv. What do you choose for those? All right, so let's look at this one. All right, so what are we going to let u equal? Well, let's let u equal x, and then dv we're going to let equal the square root of 1 minus x, but we're going to write it as 1 minus x to the 1/2 dx. Okay? So here we get du is equal to dx, and then v is equal to, well, now we got to integrate this thing. All right? So to integrate that, I mean, I guess we can kind of integrate it pretty easy, but what we might want to do here is come over to the side and integrate this, because we're going to we'll need to use u substitution on this. So u equals, so right now, just forget about this problem, the problem we're working, and let's just concentrate on this over here. So we're going to let u equal 1 minus x. So du is equal to negative dx. So you see how we have the dx here? we're missing the negative. So we multiply by -1. So that means we have to come out here and multiply by -1 because we got to multiply by a +1. So this is going to be negative integral. And now let's make our substitution. So in the place of 1 minus x, we're going to put u, and that's to the 1/2. And in the place of -1 dx, we're going to put du. And so this is going to be negative, that's going to be u to the 3/2 multiplied by the reciprocal of your new exponent. And so this is going to be -2/3, that's a 3, -2/3 times 1 minus x to the 3/2. Okay? And so here v is -2/3 times 1 minus x to the 3/2. All right? All right, so let's see what we get. So we get u times v, so that's -2/3 x times 1 minus x to the 3/2 minus, well, the minus and minus make a positive, and that's the integral. And I'm going to take the 2/3 and I'm going to bring it out. So basically what we have here, let me write it down. It's, see, according to the formula, it's minus. So it's minus, and I'm going to bring the -2/3 out of the integral. And then I've got 1 minus x to the 3/2 dx. And what I'm doing, this minus a -2/3, I'm just writing it as plus 2/3. Okay? All right, so now we just have to integrate this thing. So I mean, we're going to do the same thing that we did of what I'm erasing. We're going to need to use u substitution on it. So let's let u equal 1 minus x. du is negative dx. So you can see I need a -1 there. So I've got to come out here and multiply by -1. And so this is -2/3 x times 1 minus x to the 3/2 plus 2/3 times the integral u to the 3/2. Whoop, I'm sorry. You see the -1 and the plus 2/3? That's going to make it minus 2/3. And then we plug the u in for 1 minus x. And then in the place of -1 dx, see, negative dx, we're going to put du. And so this is going to give us -2/3 x times 1 minus x to the 3/2 minus 2/3, and that's going to be u to the 5/2, add 1, multiply by the reciprocal of your new exponent, plus c. And so this is -2/3 x times 1 minus x to the 3/2, and that's going to be -4/15. And then back in the place of u, I'm going to put 1 minus x to the 5/2 plus c. And there is your answer. All right. All right. So look, I know this right here, I want you to understand that this integrating, when we integrated this right here and used the u substitution, that's something that you should already know how to do. Okay, that just goes back to the basic u sub. Okay, that's all that is. All right, let's look at the next problem. Oh, what about this one? All right, so what am I going to let u equal, and what am I going to let dv equal? Well, I'm not going to let, just think about this. What if I did this and let u equal square root of x? What if I did that? Well, I don't know how to I don't know how to integrate natural log. I don't know what the antiderivative of natural log is. Okay, so that's out. We can't do that. So I'm going to have to switch them. And that's something that I want you to keep in mind. If you let u equal something, dv equal something, and you try to work it like that and you can't work it, we'll swap them. Okay? So we're going to let u equal natural log x, and we're going to let dv equal the square root of x. We're going to integrate it, so let's write it as x to the 1/2 dx. And so du is equal to 1 over x, derivative of natural log is 1 over x dx, and then v is, that's x to the 3/2, add 1, multiply by the reciprocal of your new exponent. All right, so now we've got u times v, so that's going to be 2/3 x to the 3/2 natural log x minus, and then that's going to be, now I'm going to bring the 2/3 outside the integral, and that's going to be 1 over x times x to the 3/2 dx. All right, so that's going to give me 2/3 x to the 3/2 natural log x minus 2/3 integral. Now, this in here, that's the same thing as x to the 3/2 over x to the first power, right? And that's x to the 3/2 minus 1, which is x to the 1/2. So that's going to be x to the 1/2 dx. All right. So now this is equal to 2/3 x to the 3/2 natural log x minus 2/3 x to the 3/2, and then multiply by the reciprocal of your new exponent plus c. And so this is going to be 2/3 x to the 3/2 natural log x minus 4/9 x to the 3/2 plus c. And there's your answer. All right. So you can see this is not, it's really not that bad. It's just, you know, the decision you've got to make. What do I let u equal and what do I let dv equal? All right, so how about this one? Inverse sine. All right, so obviously, if I knew how to integrate inverse sine, I wouldn't need to do parts. So here, I'm going to let u equal inverse sine x, and I'm going to let dv equal dx. So here I get du is equal to 1 over the square root of 1 minus x squared dx. That's the derivative of inverse sine. It's a formula. It's probably on the back cover or in the table of integrals, the basic table of integrals in your calculus book. Look at that, and you'll see that formula. And then v is equal to x. All right. So this is going to be x inverse sine x minus the integral of this times this. So that's going to be x over 1 minus x squared. And it's the square root of that, but I'm going to write the square root as a 1/2 power dx. So now to integrate this, I need to use u substitution. So I'm going to let u equal 1 minus x squared, and so du is negative 2x dx. So what am I missing? Well, you see how you see here how I have x dx? I need a negative 2. So I need to multiply by negative 2. So that means I come out here and multiply by negative 1/2. And so that's going to be x inverse sine x plus 1/2 integral. And now I make my substitutions. So I'm going to plug u in for 1 minus x squared. So that's 1 over u to the 1/2. And then in the place of this negative 2x dx, see, negative 2x dx, I'm going to replace that with du. All right. And so now this is going to give me x inverse sine x plus 1/2 integral u to the negative 1/2 du. I need to move this up into the numerator. And now I can use the basic power rule there. So that's going to be x inverse sine x plus 1/2, and that's going to be u to the 1/2. Add 1 to the exponent, multiply by the reciprocal of your new exponent, plus c. And so that's x inverse sine x plus, and the 2's just cancel, and then that's going to be u to the 1/2, but in the place of u, I'm going to put 1 minus x squared to the 1/2 plus c. All right. And yeah, you know, if you want to, you can write that as square root. Okay. That, or if you're in my class, you can leave it like that. It doesn't matter to me. I'll be happy if you get to that. All right. All right, so how about this one? Well, what do we let equal what? Well, do we know what, if we let u equal e to the x, derivative of e to the x is e to the x. If we let u equal sine x, derivative of u is sine x. If we let dv equal e to the x, well, v would be e to the x. And if we let dv equal sine x, then v would be negative cosine x. So what do we do? It's really not making much of a difference. So let's just try something. So let's go ahead and let u equal sine x, and let's let dv equal e to the x dx. So du is cosine x dx, and v is e to the x. And so this is going to give us e to the x sine x minus the integral e to the x cosine x dx. So really, this right here doesn't look any better than that, does it? So what do we do? Well, let's try parts again. So for this, I'm going to let u equal cosine x. I'm going to let dv equal e to the x. So du is negative sine x dx, and v is e to the x, and this dv, that should be e to the x dx. Okay, so let's make the substitution. So this is e to the x sine x. So that's just this part written down again, minus this integral here. Now minus, so I need to put all of this in a bracket or parentheses, whatever you want to do. So that's u times v, so that's e to the x cosine x minus e to the x times negative sine. Well, that negative sign, that negative and this negative, that's going to make a positive, and so that's integral e to the x sine x dx. And what I'm going to do is I'm going to distribute that negative, so that's e to the x sine x minus e to the x cosine x minus integral e to the x sine x dx. And you can see here we're right back where we started, with the original problem. So basically what we have here is we have the integral of e to the x sine x dx is equal to, so all I did is I just wrote the problem down again. That's equal to this, e to the x sine x minus e to the x cosine x minus integral e to the x cosine x dx. I'm sorry, that should be sine. Okay, so look at this. Well, this gives us what? 2 times the integral e to the x sine x dx is equal to e to the x sine x minus e to the x cosine x, right? So, and then, well, look, now we just multiply everything by a half. So that's going to give me integral e to the x sine x dx equals 1/2 e to the x sine x minus 1/2 e to the x cosine x, and don't forget your plus c. And so this would be your answer here. Now, some of you might be wondering, how did I get this? Well, all I did is I added the integral e to the x sine x dx to both sides. And see, they cancel out over here, and then this plus this will be 2 times that. Okay? So I had to do integration by parts twice. Okay? All right, so let's look at another problem. Now, I've got this word problem here that I'm going to work, but I'm going to come back to that in just a minute. I want to work another problem first. So that was, I think, problem 5, I guess. So let's call this problem 6, I believe it is. Yeah, that was problem 5. So I didn't put one of these on there, and I want to do an example of this. So let's say we got the integral x squared e to the x dx, and we want to integrate this. All right. So let's let u equal x squared, and let's let dv equal e to the x dx. Okay, so I get du is 2x dx, v is equal to e to the x. All right, so now I've got u times v, so that's going to equal x squared e to the x minus, and I'm going to bring the 2 out, the integral x e to the x dx. And you can see I still I can't integrate this. So what I'm going to do is I'm going to have to do parts a second time. Okay? So I hit a button with my hand. All right, so we're going to do parts on this. So we're going to let u equal x. We're going to let dv equal e to the x dx. So du is equal to dx, and v is equal to e to the x. And so this is going to be x squared e to the x minus 2 times. So it's 2 times this integral here. So I'm going to need to put that in parentheses. So that's u times v, so x times e to the x minus du times v times the integral e to the x dx. And before I integrate, I'm going to go ahead and just distribute that -2 minus 2x e to the x plus 2 integral e to the x dx. And so this is going to be x squared e to the x minus 2x e to the x plus 2, and then the integral of e to the x is just e to the x plus c. So the point of this problem is just to show you that sometimes you might need to do integration by parts twice. And look, if this were an x cubed, we would have to do parts a third time. Okay? So, just look at it, and once you do parts once, if you get something that you can't integrate again, you might can do parts on it again. All right, now let's look at this problem. We've got us a word problem here. All right, so it says, in a certain electric circuit, the current I in amps is given by the equation I equals T times e to the negative t, where t is the time in seconds. Find the charge Q to pass a point in the circuit between t equal 0 and t equals 1 second. All right, so we've got the current I and the charge Q. So I don't know if you've seen some of my previous videos or if you know this formula, but I, the current is equal to the derivative of the charge. Okay, so I is equal to this, so that tells us that dq dt is equal to t e to the negative t. And so now to get q, all we need to do is integrate it and evaluate it from 0 to 1. So I've got q is equal to the integral 0 to 1 t e to the negative t dt. And so we just got to integrate this thing. And that's going to be integration by parts. And so this is going to give me, well, let's see. I'm going to have to do parts. So u equal t, dv equals e to the negative t. So du is dt, this is dv is e to the negative t dt. And so if we integrate this, that's going to give us negative e to the negative t. Okay, so if I come over here, let me just show you e to the negative t dt. So I would let u equal negative t, so du is negative dt. And I would need a negative here, and so a negative out here. And so that's negative integral e to the what? U is equal to negative t, so that's u. And then you see the negative dt, that's going to be replaced with du. And so that equals negative e to the u, which is negative e to the negative t when I plug the negative t back in, plus c. All right, so that's where this comes from. If you need to on some of these, you may have to come over here on the side and integrate it. We had to do that in some earlier problems that we worked also. All right, so now I'm going to get q is equal to, let's see, negative t e to the negative t, right? U times v, and that's going from 0 to 1. I've got to evaluate it from 0 to 1, minus this times this. Now, the negative and the negative, that's going to be a positive, integral e to the negative t dt from 0 to 1. And so this is going to give me negative t e to the negative t from 0 to 1. I'm not going to evaluate it just yet. And then we find the integral of that, and we did that over here already. That's just what? Negative e to the negative t from 0 to 1. And so this is going to give me negative 1 e to the negative 1 minus negative 0 e to the negative 0 minus. Okay, so this part is this evaluated, and then minus, and now I need to evaluate this. That's going to be e to the negative 1 minus e to the 0. And so this is going to be negative 1 over e. this right here just goes to 0 minus 1 over e minus 1. And so that's just going to be, what is that? Negative 2 over e minus 1. Unless I made a mistake somewhere, but I don't think I did. Let me check with my calculator, because I'll hear about it in the comments. Well, I'm glad I checked. Look what I did. Minus, this is 1 right here, minus and minus. That should be, see this minus and minus, I put a minus, it should be plus. So this is your answer, which is actually equal to negative, not negative, but it's equal to 0.26 C. All right. All right, and that's your answer. So I think we got a pretty good variety of examples in this video. We got one where we had to actually evaluate the integration by parts. And like I said, if you want to see more examples of doing integration by parts, check out my video. It's on my channel. Just type in calculus integration by parts. This is applied calculus integration by parts. Okay, I know they're both calculus. I know it's both integration by parts. It's just, I mean, it's not different, but they do work different examples. The way the two calculus classes are organized are different. Calculus versus applied calculus. It's a little different how they organize and how they break the sections up and stuff like that. So that's why I'm making these videos, because I do teach an applied calculus class and I teach the regular calculus classes. So I'm doing these for my applied calculus students and for everybody else that's watching. But I appreciate you watching. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.